Bootstrap testing procedure. Bootstrap testing procedure actually first time it is introduced by Efron in 1979. This method basically based on computer intensive procedure for assessing the accuracy and the properties of an estimator, and it works by resampling the original n data n times with replacement and recalculate the point estimator. Generally we denoted it by the mean. This method works as, in this method, an equal probability of drawing each original data point for the inclusion in the resampling data. The second point, that the procedure can select a data point more than once for the resample data, and generally the procedure creates resample data sets as has the sample size as the original data. For initial understanding, we just take an example so that one could understand how the Bootstrap works. So let's study consists 5 data points and create 5 Bootstrap samples as. So you can see that the original data that is based on the 5 observation, that is 2, 4, 6, 8, 10, and when we further perform the resampling, the first Bootstrap data basically that is 2, 2, 6, 10, 10. So any possible value of the original data can be obtained 5 times because we have 5 observation. The second Bootstrap basically gives the values 4, 6, 10, 2, 2. Actually the resulting new data consists of all those values which have in the original data. जो original data में हमारी observation है वही दोबारा resample होके हमारे नए सैम्पल डाटा सेट्स बनते जाएंगे. सो इस केस में हमने 5 सैम्पल नए डाटा सेट्स बनाए हैं विच इज़ डिनोटेड बाय बूटस्ट्रैप 1 अप टू बूटस्ट्रैप 5. तो आप देख सकते हैं कि हर बूटस्ट्रैप में जो हमारा ओरिजिनल सैम्पल की वैल्यूज़ हैं वही आ रही हैं और इसमें रेपिटेशन भी हो सकती है क्योंकि सैम्पलिंग हमारे पास विद रिप्लेसमेंट हो रही है. तो यू कैन से दैट कि वी कैन जनरेट 5 डाटा सेट्स. तो इसमें जितने आप डाटा सेट जनरेट करना चाहते हैं आप कर सकते हैं. देयर इज़ नो रिस्ट्रिक्शन कि आपने 5 करने हैं. It could be 7 bootstrap data sets, it could be 10, कोई भी number of sample data sets आप generate कर सकते हैं. So bootstrap method can also use effectively in testing the hypothesis. To illustrate this technique, we consider the 2 sample testing of hypothesis so that we can understand how we can use the bootstrap method in testing of hypothesis. So for the 2 sample, how we proceed that? Observe sample 1 of size n, that is x1 up to xn, and we denote its mean by x bar observed. Again for the second sample we take the sample size of m, that is denoted by y1 up to ym, basically that is ym not n because we have n observations, and its mean is denoted by y bar observed. Observe the sample mean difference, that is denoted by v static observed, that is basically the difference of the x bar observed minus y bar observed. So how bootstrap procedure works? Combine the sample of the two, combine first and second sample, that is n1 plus m, n plus m, because the first sample based on n observation, the second sample based on n observation. The first step is that combine both samples. So it is represented by n plus m. Then the second step, draw the bootstrap sample of n plus m observation with replacement from the combined sample. तो combined sample से n plus m जो हमारे पास observations है उसका हमने sample draw करने हैं. Then calculate the mean of the first n observation which is denoted by x bar steric, and calculate the mean of the other sample which is denoted by y bar steric. And then we find the difference, that is denoted by v steric, that is x bar steric minus y bar steric. Repeat the step 2 and 3 for b. B basically represent how many times we are going to bootstrap the observation. So that is here, just for example we consider 3000 times and obtain the b value of the test statistic. So after that we calculate the p value because we are going to draw the inferences on the basis of p value. So how we calculate the p value in this case? That is p value is equal to the number of times, that is v steric, which is the bootstrap difference greater than the difference of the original data, that is the observed data, basically represented by V observed steric, and divide by the number of bootstrap, which is denoted by B. So reject H naught if the P value is less than alpha. An important point in when we are going to perform the bootstrapping, that it does not follow the normal distribution. It is not necessary that it follows the normal distribution, and the sampling distribution of all possible samples generally not follow the T distribution, because our test statistic based on T in parametric statistic. So here it is not necessary that it follows the T test, but you can observe the accuracy of your test by performing the bootstraps. So this method basically useful when we perform many times, regenerate the data, and then we say what happened with our estimator or our testing of hypothesis.